automation, and I will also show you a small demo about it. We'll have a quick look at some use cases where IT automation can be very useful, and of course draw a bottom line about what we have talked about today. So before we dive into the topic, let's quick talk about why Consol is actually engaged in doing infrastructure automation. Here you see the 4 main pillars of services that we at Consol offer for our customers. We do a lot of consulting to a lot of topics regarding cloud infrastructure, software development infrastructure, project management, and as such. We have a branch that does IT solutions. Of course, our main flagship product, the Consol CM, is developed in here. We have a branch about software engineering. That's the branch where I originate from, where we do individual software solutions for our customers. And we also have a branch for IT operations, where the systems that we build up are supported and maintained. Well, as we have quite a broad spectrum of services, especially regarding software engineering and operations, and as we are going to see later that IT automation mainly is a merging of tasks and traits between software engineering and operations, this comes actually quite natural to us and is of great benefit for us and also for our customers. So it's a big topic here. Okay, what's the story? Let's take a quite naive approach to what IT automation actually is. One would say automation or IT, doing software is actually already automation itself. Tasks that once were done by people are now done by software systems. So far, so good. But these software systems themselves are still mainly set up and built up by people, mainly ops stuff, which just, order servers, boot them up, set them up, install software in them, and wire them together in some meaningful way. When we talk about IT automation, we're actually talking about going a bit further. These systems that we use to provide services or do tasks are no more manually created by people. Instead, they are created by other systems, by IT automation systems, which actually do the same task, but of course in a different way. So let's have a look at a typical process, how usually a new infrastructure for some IT task is set up. Typically, it starts with some member of the ops team ordering, iron, say, some servers, some network hardware, anything that you need to wire the things up and to make it actually behave good, maybe even to have some high availability. He orders all this iron and then he does manual setup to it. So he connects the stuff with cables, he installs operating systems, he installs software, and by doing this, he in the end creates some kind of infrastructure. This, of course, is quite a tedious task. It takes the ops member a lot of time to do it, and it is maybe quite tedious, at least if you need to do it multiple times maybe. When we talk about IT automation, we have a different approach. The first task for the ops member here is not to actually build something up, but he actually writes a definition. This definition defines the infrastructure that he's going to build in form of some program code. You could call it program code, but it of course is a bit different. Instead of tasking processes and doing data management and all such, this definition contains information about, okay, I need these 3 servers. These 3 servers need to be placed in the same subnet, and then I need a database server, which the 3 servers are connected to, and then I need some kind of gateway, which routes traffic from the internet to these C servers. You write that down into some definition, and this definition then is used by some kind of automation tool. We're talking software here, some kind of automation software, which can take this definition and automatically apply this definition on some public cloud provider. Yeah? And the result of this will be that this infrastructure is actually created inside this public cloud. So by stating this, we have already stated what is the big enabler for doing IT automation right now. It's of course the cloud. Some software cannot actually, maybe it can maybe order some servers, but cannot build it up into some computing center. It cannot do manual setup to these if these are real hardware. Yeah, but having all these virtual infrastructure and virtual servers and entities inside the cloud, automation tools can build them up and wire them up in some meaningful way. So why is this a big deal? Why should you choose to use something like this? Well, let's talk about replay. We now have a definition, and this definition we can apply to our cloud provider to actually apply the system. But as you all know, you maybe don't need to do this once. You might need to do it multiple times. Think multiple stages of a software project. You might have a stage for dev tests where automated tests are performed. You might have a stage for staging where, well, there is some manual testing going on. And finally, of course, we have a prod stage where actually the people work on. And using the same definition for all of these three stages, maybe with some tiny different configuration to it, is actually quite handy. And all of these environments then end up being quite similar. Yeah. But that's not only limited to stages. Imagine you have a software system where you want to have multiple installations for multiple of your tenants. For example, some kind of ticket management tool or something to organize development teams. You could have one definition to write up such a environment for such teams and apply these multiple times for every of your tenant. And what you can also do with most automation tools, you can use this definition not only to create the system, you can also use it to update the system actually. Yeah. Most automation tools are built that you could run the complete definition over and over again over an existing system, and everything that's already up to the definition in that system is left untouched, while some changes you do later, maybe you need another machine, or maybe you need to increase some memory to some database, are then applied if there are actual changes. Let's talk about efficiency. Well, this should come to no surprise. If you have a definition and you give this definition to an automation tool which applies it to the cloud, this in almost all situations is radically faster than you could do with any manual work. In fact, the only limitation you have of speed is your public cloud provider, which might not be too fast giving you the resources, but still it ends up quite faster if even some ops member would click it together in some web console. Not only this, you could also do massive parallel updates. Say you have dozens of systems, for example, these tenants we talked about earlier, and all of these need to get an update. You could do this using one definition containing the update with just one call, and automation tools can then parallel. Another quite important thing to note here is that once the whole know-how, how to do something, how to build an infrastructure update is written to a definition, then it does not have to be done by the person who wrote the definition. Instead, it can do by anybody else, any other ops member that is capable of running this automation tool. So you could delegate some tasks to some people with a lower experience or know-how to perform them, which is also quite a game changer in some situations. Think about knowledge silos that are concentrated on one ops member, which result in this ops member doing all this stuff here. Let's talk about quality. I said already in the beginning, if we use the same definition to apply multiple environments, these may be environments that are stages, these may be environments that are tenants, this may be that you, after having one environment, you just recreate it because you had a complete breakdown of your infrastructure and you would need to recreate the new system. All of these result in nearly identical infrastructures. Only the parts that you need to do different between those environments are actually different. For example, of course, every one of your tenants needs his own database, and you of course have in your stagings different data in your system than you have in your production. But nevertheless, all of the rest, the setup of the service, the setup of the infrastructure is the same and is always applied exactly the same. No more slip, no more tiny different order of tasks which might result in a different result. It's always done exactly the same. Another thing that increases quality here is that your definition actually is already some kind of documentation. So imagine the times when there was a server and the server lives for about 10 years and it was once set up. Maybe somebody wrote some documentation about it, but in these years, different ops members changed it, needed to tackle some problems with it, which were already directly done to the service. And in the end, nobody knows really what has been done on the server, on what configuration is really necessary to make the system run in a good way. But here, if you only work via definitions, then this definition is actually your documentation. It is the last state of setup for the system. Another quite comfortable feature of IT automation is that most automation tools support something that's called drift detection. So before applying definitions to environments, these tools could first make a diff between the two and point out the difference that your definition has to the real living environment. So when you do this first and you see some of the difference here don't make sense to you and they might be dangerous, you might rely to not applying the definition at first, have a look why it is that way. And also you might find out if some of your other team members are still directly working on the service and changing configuration, because then we will see these changes in contrast to the definition. So the last sweet spot we have here is something that is called site reliability engineering. That is a term that was first coined by Google, I think, but I think it has come away since then. You could describe it as using some traits that were developed and used in software engineering for other parts of IT. For example, here for ops and IT automation. What we mean by that is, once we have a definition, we have code. Code can be managed in some kind of version control, like a Git repository. Using this, you can have some, you automatically have a history of definitions, have a history of what was changed in the definition and who changed it. You could even work with an issue management system to document further on these changes. You could use a CI/CD, a continuous integration delivery system, to actually run these definitions on your systems. This has the benefit of, inside these jobs that you define in the CI/CD systems like Jenkins or Tekton, you can implement the right way to call this definition via your automation tool. So again, once you have this as a job, you can just start the job and it's exactly what is done, defined in the definition in the way it is implemented in the job. And of course, once you have CI/CD, you can also think about having some kind of build and testing pipeline. You could do some automated tests into your process, like having your definition always apply to a complete new environment. Then look at it, do some automated tests on it, do some manual tests on it, and after you are done with it, you can scrap it again, so you don't need to pay for these resources for too long. And only then, after this automation, you can go into production, and you have very good verification that what you have in your definition is actually what should be done. So let's talk about the tools we use and the virtues, if you want to call it like that we use to build these systems, or how we think it should be done right. This is of course only our take on it, but as I think we're quite successful with it, so we will share it here. These are the main tools that we are using to perform IT automation. On the left, we have Ansible from Red Hat. Many people of you might already know it. It's called a configuration management tool, but I think you could rather think of it as some process execution tool. It can actually do everything that an ops engineer can do via a console, but it can do it remotely. So Ansible doesn't need to be run on the exact machine where the changes are done, and it can do it in massive parallel. So it could work with dozens or even hundreds of machines in parallel. It has some quite nice features. So the Ansible scripts or playbooks, as they are called, can be parameterized to differ between stages. You can have Ansible make your host and group management to manage the DNS names of all the servers that are involved. You can even define some dependencies between different Ansible tasks, which are called roles. So Ansible can do them in the right order. Ansible generally can be applied to Linux and Windows targets to do any of these things. In the middle, Terraform from HashiCorp is something that you would just call an infrastructure as code software, as that's what it is for cloud resources. Terraform supports all of the big public cloud players that we are known of here, like AWS, Azure, and Google Cloud, but also Alibaba and some other. In Terraform, you do just the things I said earlier. You say, okay, I need these 3 servers, and I need this network, and I need this database. You define it in some infrastructure code, and Terraform is able to apply this then to some cloud target. Terraform has also a very good drift detection, so Terraform can find out how your current definition differs from what is already applied to your target. On the right, I chose Tekton as some CI/CD system. I could have taken any of the others that are lined out below, like Jenkins, GitLab CI, TeamCity, or Argo. We generally recommend to use some job running software, some CI/CD software, and to use it to define the jobs to run this automation for improving quality. But any CI/CD tool will actually do the job here. We chose Tekton because it is a very exciting, quite new project, which does CI/CD in a cloud native and especially Kubernetes native way using operators. And it's our go-to solution for right now for most situations. So without all this talk done, let's have a look at how actually these tools are used. We are going to see a project which uses Ansible and Terraform to build up some infrastructure. A word of caution at first, This is no tool project. This is also no hello world or something like this, but it is actually a production grade project which does a lot of stuff. The project I'm going to show you is quite large. It has a lot of folders, a lot of files. If you're like me, I don't like it when in webinars or the like, we only have get shown very small hello world demos, which might show you, okay, this software exists and can do the following, but which has no relation to actual production environments. Here I'm showing you a real life project which does important stuff. It might be, therefore, the first look might be a bit overwhelming, but we're going to go through some steps which I hope are quite easily to be understood. Below this, you see what does it actually do? It creates a complete environment for a new software project on AWS from total scratch. What does a software project need? Well, it needs some kind of deployment platform. We use here the Kubernetes solution from AWS called EKS. And what does it also need? It needs a database. We here let the project build a PostgreSQL database cluster for this. And we also put a lot of stuff into the Kubernetes cluster. We set up the complete networking on it with 2 VPCs and 6 subnets. We deploy an ingress controller into the Kubernetes cluster, which is responsible for getting traffic from the internet. We do already a Tekton installation, so we have a CI/CD server ready. We already do a build pipeline for application images. We already set up the build trigger for the Git repository, so commits to the Git repository automatically trigger the builds. We create a Docker registry in AWS where to put the images. We set up some roles. We set up an S3 bucket. A lot of stuff, actually. A very complicated infrastructure, which setting this up manually would maybe take you days. Here we have this in one script. And what the script can do is not only create all this stuff, it can also delete all this stuff again if we don't need it anymore. So with this said, let's head to my development environment. This is a project. We have some part here for Ansible control. This project generally is set up that both Ansible and Terraform are used, but you can generally choose if Ansible is used to call Terraform, or if Terraform is used to call Ansible. Yeah, so these tools complement each other at some parts, but you should have one leading tool with which you're working directly, and this should actually trigger the other tool. So we have here something that's called an Ansible playbook, just a YAML file. Ansible works completely with YAML. So what have we do here? What have we done here? We have some tasks here that are done. Of course, these are not all too interesting here right now. We include some stage information, so we are able to deploy this infrastructure to multiple stages. And then we have some so-called Ansible role called infra do all, which will actually apply all of the things we want to apply. We give it some AWS information here, and that's all for the actual call. This file is what gets actually called via Ansible, and which we will see later. This role here, infra do all, is hosted in a roles folder. You see, we have quite a number of roles here. Each of this role does a different part of the installation. This infra do all role actually is some meta role which calls all the other in some meaningful combination. We will have a look here more deeply into this role. This is AWS infrastructure. This is an Ansible role, which in the end calls Terraform to apply some Terraform definitions. So let's open it. There is some tasks folder, and here we have the actual tasks. So let's look into this infrastructure YAML. This is a bit larger. Here you see everything that starts with a dash here is actually a task, a single task that's executed. So we first create a temporary directory here. Then we have a block of multiple tasks that go belong here, where the Terraform files, where the definitions are copied to this temporary path. And in this task, we call a Terraform module, which just takes these files and gives them to Terraform. We also do some kind of parameterization here. You see there are a lot of variables giving to Terraform, which come actually from Ansible variables here, and some config about the Terraform backend. Let's have a look at the actual Terraform files that are applied. These are in this Terraform subfolder. So here we see RDS. This, for example, is the definition of the DB instance, the Postgres instance. As you can see, also Terraform supports many ways of parameterization here. So for example, the root password to be used here comes from some variable from outside. You wouldn't want to have this inside this project. Let's also have a look at this. We also defined some kind of bastion host. This is a host that we use to do SSH connections into the AWS network and work from there, for example, for debugging. Actually, this is a networking regarding it. And this below here is the actual instance. We are giving it the AWS instance type T2 micro. So this definition, in fact, was already applied to some AWS account, which I have here. The reason for this is AWS takes actually some time to create all these resources that we want to create, for example, the Kubernetes cluster or the relational database. So this would not be possible in this talk, but we will have a look in a minute how to update this infrastructure. So what do we have here? This, for example, is a Kubernetes cluster. We see we have created a Kubernetes cluster. It's of version, don't let me lie, 116. And we have 3 worker nodes defined here where the actual deployment happen. We have a relational database that was created. It's in here. So this is a PostgreSQL. It's of size dbt3 large, and it has nothing to do currently because nobody's working on this. So, and what we also have, which I want to show you as a last point, is under EC2. EC2 are, for those who don't know, what AWS calls virtual machines. We have 4 here. These 3 are actually our worker nodes for Kubernetes, the 3 at the bottom, which we don't need to manage directly. And this up here is the bastion host. I can click on this and have some information about it. For example, all the resources in AWS can be marked via tags, and we only have here right now 1 tag. It's called name and has this contents. So imagine we want to add another tag to this machine. To do this, we can go back into our definition here, and we see this is our bastion instance, and we already see the tag defined here. We have a name and then a bastion dash with some variable after it. So I can now add another one, maybe just call it N for environment and say this is a test environment. And so I added this here. Now I will go into some console. Here, this console is actually inside the Ansible folder of the project. And what I now do is I call Ansible. I say, run an Ansible playbook, and the playbook that you run is this infra YAML. Now to say it again, this infra YAML incorporates all the stuff that is built into this environment, all the networking, all the machines, the Kubernetes cluster, the relational database cluster, and the such. But as Ansible is something that's called idempotent, it will just update what is really different from what is in the definition. So I expect it to leave everything else untouched and only update the bastion host. So let's run it. What you now see here is every line with these stars here is a separate task that is done inside the playbook. There are quite a lot of them, and Ansible already always answers with a OK if it checked the target to be already on the right state. If it is on the right state, it only says OK. OK means OK, I did nothing because this was already in place. So we will wait until we run to the task where I actually expect Terraform to do something. This might take some seconds, but most of the time it's fast enough to have a live look here inside the webinar. So now we have this create temp Terraform directory, which we saw earlier. And now we have this infra apply. Now this is the task I expect to actually do something, because this runs the Terraform files on AWS, and we change the tag on the Bastion host. And I expect it to actually find this and do some update. And I also expect it to finish, well, in not too far time, so we can give it some time to wait for it to finish. Yes. Now you see this is yellow and it says changed. So Ansible saw that Terraform, which was called by it, actually did something. And you see, okay, we had 50 tasks to do. All of the 50 were right in place, didn't have to do something, and only one was changed. This in practice is quite a big help from doing tasks like this via scripts or something like that, because you almost never have to think about what state your current system it is in, and if you can run now this script on the state of the system. You actually run the complete definition over and over again on this over the same system, and can be assured that only what is changed is actually applied. And if you're still somehow unsure, you can do a drift detection and let these tools tell you what is actually to be changed before applying it, and then be even more sure. So let's go back to the AWS console, and what we are now expecting to see if we update this is that it has added another tag. So see, we have now env test here. For that, it didn't need to restart this instance, it just added it, so impact on whatever is done on this system is quite minimal. Okay, so that's the demo. So let's sum up about some of the virtues which we actually follow when implementing IT automation projects. We want to have our tools to be quite independent of the platform we're using it on. Public cloud providers have their own tools of doing infrastructure as code. For example, AWS has something called CloudFormation. But learning this will tie you actually to this platform. And this is something that we have in mind in all of our cloud projects. We want to be as independent from the cloud provider as we can be. Therefore, we're doing Kubernetes, and therefore we're using tools here which are completely independent of the cloud provider, like Ansible and Terraform. Of course, when doing AWS infrastructure definition in Terraform, you can't actually get along without addressing some specific AWS infrastructure elements. You see, infrastructure is a bit different in these public cloud providers, so also the way to build them and address them is actually different. But if you someday say you want to go to a different cloud provider, or need for a new project to reuse some things to something that uses a different cloud provider, you already learned about Terraform and how to use it. You already learned about Ansible and how to use it, and all you need to do is to update your definitions accordingly. In the middle, on the top, immutable infrastructure. This is something that is mainly used today in containerized environments like Docker runtimes or Kubernetes. Generally, it says a system that you have built should never be changed. If you need to change, you should actually rebuild it and scrap the old one. Yes, that's not always possible, of course. Some servers need to stay that way and cannot be hot swapped or something like that. But generally, when the situation allows it, IT automation enables it to do so. For example, as I said earlier, you can have some staging systems where you do tests. You create them before the test, you test, and after you're done testing, you scrap them again. On the top right, idempotence, we already talked about. Actually, it means you can run the same script over and over on your system and only changes will get applied. I already talked about what makes this a great thing. On the bottom left, use a job runner, use some CI/CD system. Actually, what I did here, running Ansible via Consol, should be the exception. Everything that is done multiple times in IT automation should be defined as some job, which you then just have to run. So you are even have more quality here. On the bottom, in the middle, embrace site reliability engineering. Use everything as code. Use version control. Do automated tests and use CI/CD. And the bottom right, if you can do it, you should maybe prevent if your company builds multiple approaches to IT automation. This again would increase complexity here. Maybe first build a framework that suits most of the cases, that is flexible enough for anybody else to use, and make it readily available to everyone. So have some quick look really about some use cases about IT automation. I think there are a lot of use cases actually, and most of them aren't currently not really thought of being a use case for it. So I will sum two of the most used up here. For example, I talked about this earlier. We have this multi-tenant installation of software. A company uses multiple instances of a non-trivial software system. We're not talking about installing Notepad on Windows systems. We're talking about a software system that is complex, which not only has one deployment, but maybe consists of multiple services that interoperate with each other. You could think of a big CRM solution, an issue management system, a process management system. And the system is used and to be installed for multiple tenants. And maybe this installation for each tenant may differ. Yeah, we had this situation actually with some customers. For example, one tenant needs to have every subsystem of the complete software system running on a separate server because he works very intensely with it. So he has the right performance. Other tenants don't need to use this and might need to cram multiple of these subsystems on the same server. They might need different types of subsystems, and this results in widely differentiating tenants where each installation is quite unique. But of course, you don't want to manage each one as if it was a separate system, especially if you don't not only install it, but you will also need to roll out updates for it, or you might even need to test the updates in some staging systems. Doing this manually and installing each and every tenant, then updating it and testing it is a very tedious task, and there's a lot of things that can go wrong if every tenant uses his own installation. What can be done instead? So the ops engineer can instead write a definition. This definition suits all of the tenants and leaves room to parameterize every actually appliement of this definition to what the tenant needs. He also writes these configurations of the tenants down into some config file. Yeah, also have it as code enables you to work better. And then actually you can use the definition in combination with some tenant config to create your tenant software, also to create staging system and to update these staging systems. I have differentiated here between manual tasks being displayed in dark gray and high, and automated tasks being displayed in white to display that these automated tasks are quite faster and easier to do. So this is actually a way that you can manage such an environment. Not only do you have a written down config about what each tenant actually system is built of, you can also do an automatic apply with the same definition to actually work with it. There are some variants to this use case. For example, if you are offering training courses, and these training courses, the participants in these training courses should work on some cloud machines, cloud shells, or something like that. Maybe you need a database or something like that for your training. You could create a definition which sets up a complete training course environment with all the participant machines and the central infrastructure needed. You can apply it for each course. So every participant has a very clean environment. There are no things left back from the earlier course, because this system is completely new. And after the course finished, you can scrap the whole environment again until you need again. You can distribute client software using this strategy. You can also create, like we saw in our demo, software development systems for them, no matter how complicated they are. So a second use case, let's think about user self-service. Let's think about you have some internet portal by which your portal users can request special services. These services are assigned mostly to some ops engineer. The service, whatever it might be a new deployment, or the offering access to some system, or some membership booking for some event. The ops engineer does manually the service setup. At some point, often he needs some feedback by the user. The user provides this feedback, on the ops engineer finally finalizes the provisioning. Well, this works, of course. There are, of course, maybe some delays here in process execution, and a lot of manual work that is very repetitive. There might be room for improvement here. What can be done? Of course, this process has some parts that need to be done manually, but you could always think about replacing some of the tasks that don't need to be manual by automations. Yeah, for example, on many processes, the ops engineer might need to do some research first to have a look at what the service needs to actually be provided. If the user already has it, if the user has the necessary rights to do it, this could be automated by some service setup script. It performs the first service setup. It might already trigger the needed feedback by the user via email or something like that. The feedback gets back to the ops engineer, which already has some data from the service setup and has already the feedback by the user. He now can do the task completely on himself, or he might input all of this data into, again, an automated script as parameters, and let the rest of the provisioning be done automatically. Variants, well, this might be applied to any type of process parts where parts can get automated. Think of workflow engines at the such. Think of incident management, something like this. So this might be applied to a lot of situations. Okay, let's sum things up here. The bottom line, or how to actually get started. So what do we think about IT automation? We think IT automation increases quality and therefore reliability. You can recreate systems in minutes if you need to. You can actually know what is installed by definition, no more guesswork about what's needed for a running system. Anyone can do complex tasks, so more people can help you out in case of trouble. well, even your knowledge silo in ops might go to holiday at some time, or might be sick some days. That way, other people might actually do what his know-how is, where his know is needed. It helps to save time and money. Everything is quite fast. You can do some rollouts of software in quite small time. The tools and strategies are hardened and production ready. We use them in almost all of our projects. And there are some more use cases that you might be aware of. Anytime you come across a manual task to set up and modify some IT, you might find yourself thinking how it could get automated. What's a good plan to start? Well, of course, at first you would need to do a bit more deep diving into automation. You would need to learn the concepts and tools we talked about here. And the best way is always to actually start with some kind of pilot. You could identify a use case for you that either is quite easy to implement, there is not much that is unclear about it, or something that promises the greatest benefit, some system or setup task which already now takes you more time than is really good, and plan a pilot for it, and then, well, get your feet wet on it, build some IT automation on it, and make a concept for running it. If you are looking for help for this, if you want us to help us, you might want to check out the link on the bottom left under consol.com IT automation training. We offer IT automation trainings which actually go through these 3-part step, and in the end you should be having some kind of pilot system, some kind of ready and working IT automation code that you can to use to automate the first tasks, and which might also be your starting point for enhancing other tasks with automation. That's that. And what I also would like to tell you about is the next webcast in this line of webcast, where we go even deeper into IT automation. We are talking about deploying applications to heterogeneous targets on 7th of October. This is done by my colleague Christian Hilgers. Okay. So thanks for listening. We're at the end of this talk, so maybe this would be a great time to answer some questions, if there are any.
I have one. Okay, sorry. So first, thank you, Oliver, for the show, and I have one comment already. If anybody has any other question, please write them in the chat. Pretty at the beginning, someone said, but automation is also useful in on-premise data center hosting environments. Do you have any experience in that? So if it's not in the cloud, but you do it on your own hardware?
That is right. That is absolutely right. If you have some private cloud infrastructure, I just call it cloud right now, that is able to set up virtual infrastructure and systems, you can already do that. Yeah, imagine you have some VMware service at your on your on-premise. You can also automate that. The key point is the infrastructure and machines needed need to be completely virtual, and you should be able to completely automate creating and updating them via code. Does that answer your question, Michael?
I would guess that should be answering the question. One other thing is what, at least for somebody who wasn't quite sure, is from what you wrote, it looks like you tear it down, you build it back up again, which is of course nice and sensible. But in many cases, if you want to change something, if you want to modify something, there is data in there. So how do you deal with that? Because then you cannot simply tear it down because your database would be gone. And that's all the stuff you have. And that's what's essential because it's you're not doing these, like I read it, these things for themselves, but because you want to have a service, and that service contains in many cases data.
Yeah, as I already said, that's of course not be doable in all situations. The examples I did was about staging environments where you only need actually the environment at some certain point. Yeah, if you think about how Kubernetes does this, there you have actually deployments which are immutable. If you do everything with application images, you don't really modify a running container to update what's in there. You just update the image, shut down the existing container, and pull it up. This, of course, doesn't work for data. Yeah. So the data store, even if this container software is connected to some database or some data store, this data stores of course needs to stay. Yeah, sure, and cannot be completely rebuilt. That's right. But there is still plenty of other stuff in IT which can work that way, I think.
Okay, thank you. So, yeah, it's getting close to 12. I have no other questions in here right now. So I'll give you another minute or so to speak up. And otherwise, I think we have answered everything that people wanted to know. Yeah. So I guess that's it. From you too, thanks for everybody for staying. And I hope this was interesting, and maybe see you again next week. Goodbye.
Yeah. Also, thanks from me, and goodbye. Have a nice day. Bye-bye.
Bye-bye.